S2-bromobutane reacts with sodium hydroxide and acetone at room temperature. There are two possible major products. Give both major products. Are they optically active? Explain. I highlighted that it reacts with sodium hydroxide because it means it is the nucleophile/base in this reaction, leaving the acetone to be the solvent. I then knew I needed to have two products, which meant most likely that they were from different mechanisms. To figure out the reactions, I looked at the nucleophile's properties as well as the solvents. I found that the nucleophile was strong and the solvent is polar product. Both of these favor an SN2 and E2 reaction. When looking at the first reaction of SN2, you can see the nucleophile attacking the backside of the substrate. This causes the leaving group to start transitioning away from the molecule. Once the transition is complete, you have successfully replaced the bromine with the hydroxide and have a bromide as a leftover ion. This compound is chiral and is optically active. I also want to note that the dimensions of this change as well. So starting off, our molecule had the bromine in the back, but now once you switch those groups, the OH is in the front. So we started off with a S, and now we will most likely have an R. Then you go down to the E2 reaction. This one's a little bit more complex. What you can see is that we have a nucleophile that is negatively charged. Since it's negatively charged, it is willing to give up a pair of electrons, and it's going to be attracted to that primary hydrogen that's closest to it. This then starts moving the electrons around within this molecule. This will result in the bromine leaving the molecule and a double bond being formed. You can see this double bond and these electrons moving around represented within the transition state with the dots. Then left over, you will have H2O, which is a combination of the nucleophile and the hydrogen from the previous compound, as well as the bromide ion for the leaving group. This compound is achiral, meaning it will not be optically active. I also want to note that the E2 reaction is more likely to happen and has a higher percent chance than the SN2. And this just has to do with steric hindrance. This problem was very difficult to distinguish what reactions would take place. At first, I thought it was an SN1 reaction with two enantiomers as the final product. However, when reading over the question, it is clear that the NaOH is the nucleophile and the acetone is the solvent, which would make it impossible to be an SN1 since we have an A-product solvent as well as a strong base. Let me know what you guys think. Thanks for listening.